Hi students.
Oxidation number. Oxidation number is the real charge or hypothetical charge. Hypothetical charge means imaginary charge of one atom of an element. Say 3 atoms are taken. These are losing the electrons. 1 electron, 2 electrons, 3 electrons. So these oxidation numbers are taken as +1, +2, +3. These are 3 atoms, X, Y, Z. These are gaining the electrons. How many electrons? 1, 2, 3. Since they are gaining electrons, the oxidation numbers are taken as -1, -2, -3. These are real charges. Sometimes it may be imaginary charge also. This is called hypothetical charge. Take the compound AB. In the compound, atom A loses 2 electrons. This is real charge. Based on the real charge, we can imagine the opposite charge there. That is imaginary charge. This is also called oxidation number. I will give you one more example. Take the compound XY. Y has real charge -3. It is able to gain 3 electrons. We don't know about X, but imagine the position of X here. That is imaginary charge. This is also called oxidation number, hypothetical. So understand that oxidation number is the real charge or imaginary charge on one atom. Rules to calculate oxidation number. Each atom has some oxidation number in the free stage or compound stage or ionic stage. Observe these 2 examples, silver and silver chloride. Silver is an element which is in free stage. Silver chloride is a compound. When you compare, the oxidation numbers are different. Silver shows 0 oxidation stage, but silver in silver chloride shows +1 oxidation stage. Sometimes in compound also they may have 0 oxidation stage, but when element is in free state, that will have 0 oxidation state only. The sum of oxidation numbers of all atoms in a compound is equal to 0. See this compound ABC, in which the elements are A, B, C. Element A has +2 charge, B has +4 charge, C has -6 charge. Total charge is equal to 0. Understand that the sum of the oxidation numbers of all atoms in the compound is equal to 0. This is a rule. Third rule. The sum of oxidation numbers of all atoms in ion or radical is equal to net charge. So the sum of oxidation numbers means sulfur plus 4 oxygen atoms oxidation numbers. When you add, it is equal to -2. Take phosphate ion, it has charge. Oxidation number of phosphorus plus oxidation numbers of 4 oxygen atoms is equal to -3. Similarly, ammonium ion also, net charge is +1. Let us talk about a reference table to get oxidation numbers of all other elements. This is a reference table. First group elements show +1 oxidation stage. +2 group elements, second group elements show +2 oxidation stage. Fluorine always shows -1 oxidation stage. There is no exception. Hydrogen shows +1 oxidation stage. Oxygen shows -2. The last one. any metal you take in metallic organelle. The oxidation state of metal in metallic organelle is always 0. What are first group elements? Alkali metals. Alkali metals are lithium, sodium, potassium, rubidium, cesium, francium. These always show +1 oxidation state. Second group elements, alkaline earth metals. What are alkaline earth metals? Beryllium, magnesium, calcium, strontium, barium, and radium. They always show +2 oxidation states. In this table, all elements show fixed oxidation states, but sometimes the fourth and fifth, they show different oxidation state. In metallic hydride, it shows exceptional behavior. Generally it shows +1 oxidation state, but in metallic hydride, it cannot show the oxidation state. Oxygen. It is generally -2, but in the case of this compound, it cannot show -2 oxidation states. Generally, hydrogen and oxygen are used to calculate the oxidation numbers of remaining elements. So hydrogen and oxygen are called reference elements. The exceptions in the oxidation numbers will be discussed in the next video. Let us solve some simple basic problems on oxidation number. First one, calculate the oxidation number of manganese in potassium permanganate, KMnO4. Oxidation number of alkali metal is +1, potassium alkali metal, manganese not known, it is X. Oxidation state of oxygen is -2. Substitute these values, 1 potassium +1, manganese X, 4 into -2, 0. Now substitute here, what we get? -2, -8, 0. From that, what we get? +7. Understand that oxidation number of manganese atom is +7 in KMnO4. Let us take second example. Calculate the oxidation number of chromium in potassium dichromate. 1 potassium atom, alkali metal +1, chromium not known, oxygen -2. Substitute the value, 2 potassiums, 2 into +1. 2 chromiums, 1 chromium X, 2 chromiums, 2X. Oxygens, 7 into -2, 0. Now, 2X +12 +6. So, oxidation number of 1 chromium atom is +6 in potassium dichromate. Calculate oxidation number of sulfur in SO4 -2. It is not a compound, it is a radical. When it has positive or negative charge on the top, it is a radical. Oxidation state of sulfur is X, unknown. Oxygen is -2. From that, see, it is an ion. So total oxidation number is not equal to 0. Net charge is -2. You must balance it up to -2. So what is the charge? +6. Calculate the oxidation number of nitrogen in ammonium ion. It is also radical. So here oxidation of nitrogen is not known. Hydrogen +1. Net charge is +1. It is not equal to 0. Total oxidation number is not equal to 0. It is equal to net charge. Substitute in that, what we get? 4 hydrogens into 1. Total is equal to +1. So 1 nitrogen atom shows -3 oxidation state. Let us meet in the next class. Thanks for watching. Drop a like, leave a comment, and don't forget to subscribe.